plenty of time for a few questions, so I'd like to open it up to everyone. So raise your hand or just jump in, turn on your mic and ask away. No, so while people are thinking, I'm going to ask one thing. Is there any particular reason why you went with a regression model for the learning of K initially? And part of the reason that motivates the question is that there is this thing in security, which is adversarial machine learning, where you're trying to create instances that defeat the learning, that prevents it from happening. And I was wondering whether you had looked at issues in that direction and whether you had any insights, whether this could be an adversarial strategy to prevent the learning from actually working.
Oh, it's a very good point, Laurent. To be honest, the regression looked like a natural way to go because we are at this point. So originally, we were really like try to predict the value of K. Then Matteo came into the play and suggested this simple trick that is the idea of saying, when I solve the LP relaxation, I can get this distance between the LP value and the current solution that is telling me more or less what is going to be the size that I want. And now for this reason, now we transformed the learning over a parameter which is just in 0, 1. So like we have a range between 0 and this value, which is the distance between the LP solution and the size of the essentially LP solution and the integer solution, the initial solution. And in this way, we just have to learn a 0, 1 value, a continuous value into 0, 1. And so for that particular case, it looked like a regression was actually the right way to go. We didn't try adversarial ideas on this, so it could be an interesting evolution and looking at, but it was actually, it was already working relatively well by doing this learning over the value itself, while after we did this small modification, it worked even better. So we kind of were happy about that because we had so much to think about and generalize. I forgot to say, so it's still a work in progress in the sense that even if we have a version, so the results that I'm presenting today, some of them are not even in our AAAI submission and on the generalization on the final generalization. And in addition to this, we are trying also now to generalize to say we can learn over also the computing time. So how much time do I give as a time limit? So again, there are plenty of other things to do, but it's a good suggestion.
Cool, thanks. David, I think I saw your hand up a little earlier, then we'll go to Nando after.
What about the generalization about the approach? In the future, do you think that you are going to...
David, can you speak up because we barely hear you?
Okay. About the generalization about the process, do you think that you are going to find you have to rebuild the process of learning for a given type of problems, or do you think that you are going to find some general
well, that's a very good point. So personally, I was very doubtful. So far, whatever I did in this context, I really needed to be, for example, in the branching work that we have done and in multiple papers, we never been able to do any generalization, which was actually not across classes of instances, unless you take very heavily into account the evolution of the process. So we have a paper in AAAI last year with my former student, Giulia Zarpellon, in which we were actually trying to learn and generalize using the characteristic of the branch and bound evolution for selecting branch. This is actually showing some promises, but it's very hard for branching. In this particular case, the last results are telling me that, I mean, overall, we have learned over a heterogeneous set of instances in the regression side. So for reinforcement learning, we don't care. So we can do it without, we can generalize very well. For the other one, we are somehow at the beginning still concentrating on 3 classes of problems, but the generalization over GISP and MIPLib is quite good. So we still, this is a fairly new thing, so we still working on that, but I have the impression that in this particular framework, probably 0-1 problems are sharing enough characteristics to actually check, in a certain sense, let me rephrase in this way. The type of thing that we're doing, even if it's connected to the structure of the matrix, still is very much connected to the characteristic of the neighborhood, which is still an amic distance, and so it's very similar in any one of the problems. So I have the impression that we can go further and generalize quite well.
All right, Nando, go ahead. It's probably the last question. We have two minutes left or so.
Thanks, Laura. Thanks, Andrea, for a wonderful talk. Just a quick question. So especially in the regression task, is there any precaution that you had to take in terms of data regularization? So do you have to manipulate your inputs to scale or normalize them?
Fortunately, this is again going to David's question. So I think that there is some sort of well-behaving structure here, because what we are, and in particular after we applied this idea that I was answering to Laurent. So the idea is I'm computing first the LP, I get a value, and then I use the X that is the original solution, and I do a distance between these two solutions, the fractional solution and the integer solution. This is the maximum K that can make any sense, because otherwise, I mean, if we K larger than that, nothing is going to happen, or smaller, and so everything must go between this 0 and K, and so there's a sort of implicit normalization that is happening there.
Thanks.
All right. Definitely. Thank you very much for that wonderful and inspiring talk.